Good afternoon and welcome to this webinar of the Academy of Technological Sciences and Engineering. It's a wonderful opportunity to talk about national capability and how we might improve that in Australia in order to grow forward our technology-driven futures for this country in a way that is economically, socially, and environmentally effective, useful, and balanced. Let us, at the start of this, acknowledge the traditional custodians of the lands on which we meet. In our case here in the ATSE Academy office in Canberra, the Ngunnawal and the Ngambri, and to recognise their excellent and important science contributions, as well as to respect their elders, past, present, and emerging. My name is John Dixon. I'm chair of the ACT Division Committee of the Academy, and I'll be assisted by colleagues through the course of this, including notably Andy Shepherd, who is the events coordinator, and he'll run us through the discussions after we have two superb presentations. We'll come in just a moment or two to that. But as a couple of words of introduction, it occurs to me that national capability is a term we throw around very loosely, and we don't often think very much about substantively what it means and how that national capability might be used effectively and efficiently. To have the capability is one thing, but to use it and deploy it in effective ways is another. It's a very broad concept, goes from physical infrastructures through to human capabilities to use that infrastructure, and of course, touches on important questions related to resilience in our climate and other threatened futures. So it's such an important topic for us all. I have the great pleasure now to introduce our first speaker, Professor Anna Moore, who is Director of the Institute for Space at Australian National University, or InSpace. She is also Vice Chancellor's Entrepreneurial Fellow at ANU. She has did her PhD in connection with University of Sydney on the Narrabri telescope, and spent many years through Caltech with a distinguished research career, and also a lot of advising and consulting work, both in the US to NASA, for example, and also to the Australian Space Agency. So in a moment, Anna will speak. Our other speaker, Eleanor Huffington, most unfortunately had to withdraw at the last minute. And we have got the pleasure to have Peter Derbyshire speak after Anna for just a few minutes about the launch of the new national science priorities within Australia and the implications for national capability. After which we'll move over to Q&A and general discussion. So without further ado, please, over to Anna for your presentation.
Thank you. Thank you very much. Hi everyone. That was a wonderful introduction. Thank you. It's really fantastic to be on Ngunnawal and Ngambri country with you today. I also pay my respects to their elders past, present, and emerging. So today's talk is going to be quite informal. It's a primer on what we're doing at ANU and with our multidisciplinary institute. We started 5 years ago. Please feel free to ask questions as we go along. I'm not sure what your normal thing is, but really just wanted this to be quite informal. Also to give you maybe a introduction to what's been happening a little bit in the space sector in Australia and globally, and where I think our opportunities are, not just for ANU and InSpace, but maybe a little bit more broadly over the next 5-10 years. I'm quite new to ATSE, so I was a fellow brought in last year, which is wonderful. So I thought I'd just start with a slide about me. So sounds very selfish, but I thought I'd just share a little bit before I got going. I'm sure you can maybe tell from my accent or not, I don't know. I was raised in the UK in Sunderland in the northeast of England, very traditional, low income area, love their soccer, love their footy, shipbuilding, coal mining, that kind of thing. That's where I was brought up. But I've been very fortunate on where I've gone since then, and where I've worked and where I've studied. And so that's included coming to Australia for the first time. So I worked at University of Sydney for my PhD. I'm an expert in large telescopes. I'm an astronomer by trade. So up until 5 years ago, I would be spending most of my time in very remote sites, like in Chile or in Siding Springs or in the South Pole, working on telescopes and instrumentation for that, peering through dust to see things that are normally hidden. I've worked in Italy and Florence. That's a picture there of the Arcetri Observatory, where Galileo was put under house arrest. For any of you historians, house arrest for Brit is very interesting. So I was in Florence going, really, is this house arrest? This is not to me. This is great. I'm sure it wasn't like that at the time. And I also spent 12 wonderful years at Caltech too. That's that funky building, a little building there too, building telescopes and instruments there. But a real highlight was when I was brought back to Australia, if I may say so, coming to ANU for the first time. And I spent the first 5 years running the Advanced Instrumentation and Technology Centre, which is an astronomy and instrumentation centre here in Canberra, located on Mount Stromlo. And I certainly encourage you to go and visit that anytime. But when we started our journey here in Australia 6 years ago, on what are Australia's space ambitions, broader than astronomy. So what does space mean to us? What are the opportunities for space for Australia, and what are the opportunities for our capability to be stepping up internationally on the world stage? These were really important questions raised 5-6 years ago at the beginning of our own space story, again with the space agency. And it made me think, well, you know, astronomy's own, it's obviously I love astronomy, but it's a small part of what space means. And so I jumped out of my comfort zone a little bit, proposed to ANU that really space should mean a whole of multidisciplinary response, and the whole of ANU should be there, proving, underpinning, being an engine for our space agency growth. So that's why I started InSpace. And it's okay to step outside your comfort zone sometimes. So I often start talks with what does space mean on Earth? Often when two people are asked, what does space mean to you? Or what do you think of when you think of space? You get very different responses, and none of them wrong, none of them wholly right. And so often people think of space being a one of exploration, which is a wonderful thing to think about. It's very visionary, very inspiring. They think sometimes of satellites. They think of Mars and going to Mars or the moon. What they don't naturally think about is what they depend today, you know, every minute of every day, what they are currently depending on that is up in space. So I always start my talk with this slide. And so let's start with our weather plot there. So in fact, I was on a call with the Bureau of Meteorology this morning. It's a wonderful agency here in Australia. They were there to remind me that they work with 90 separate satellite missions to be able to have access to that free data currently. That goes into all of their weather prediction models. Those models are used by us when we look at our app when we get up in the morning, but also they're integrated with companies, with agriculture, with automation. So we heavily use not just weather data, but the forecasting ability that's also increased with sophistication in the last sort of 10, 15 years, especially due to satellite data. The space component of global health, telehealth, for example, is very significant. We're seeing a huge increase in that. Being able to diagnose, be able to advise, especially remote communities or people in remote areas, being able to, to provide that telehealth solution. Earth observation is about 17% of everything we do in space. This is everything from imaging, spectroscopy, of the whole Earth, a continental scale, which is only provided by really from space. I was talking to Michaela this morning, who's here in the front row, and who's working on a project in Cape York called Aquawatch, which was a new project about how do we, from space, understand our surface water quality, and how can we therefore do something about it. So Earth observation is become a very important part of the global economy, actually. Bottom left, disaster alerts, disaster mitigation. So these things, when people are in a need like this, they tend to be in remote locations with not much access to infrastructure. Again, a whole of Earth navigation system, for example, is able to pick up those alerts and be able to provide quick response. GPS is pretty fundamental in what most of us do now. Augmented or really stimulated by one of the first investments in space hardware, which was the navigation constellation. Providing a whole of Earth reference grid where you're able to know where you are relative to anyone else or anything on the planet, because you have this network above you. We're seeing, oh, that wasn't me. That was really cool. Well, I like that. That woke everyone up. I shall do that in one future. Space is very much a domain for national security. It's certainly has been always. How that's changing with commercial space now is really interesting. If you think of things like the Ukraine war, what SpaceX was able to do in terms of providing backup communications within that context changed the state of the war, and this is pretty big stuff, but that's kind of what space can do, especially new space. And lastly, disasters like not disasters, but how can we use space as a way to adapt to what we know is coming in the future with respects to climate change, for events such as large bushfires, for example. How can we think outside the box a little bit, use space and space architecture as a way to somehow change that paradigm, especially for a country like Australia and its regional countries that really are facing quite a difficult time with the advent of climate change and hemispheres bumping into each other, summers bumping into each other from northern to southern hemisphere. I wanted just to put this slide up to show, it's not all about money, but it's good to show how economies compare to one another to give you an idea of what we're talking about with space. This is quite an old slide. This was from 2 years ago. So the numbers on here have all gone up by a factor of 50% in the last 2 years, which is an amazing statement in its own right. But 2 years ago, the global space economy, which is all hardware in it, ground services and data that we're able to get from space, was around about $500 billion in total. It's very much in specific areas though. So a large amount of it is in navigation. A large amount is in communications. Smaller is in Earth observation and launches about 10%, something like that. But this just gives you an idea of what the makeup is, from a financial perspective. There's a great report from McKinsey. They worked with the World Economic Forum very recently, and they've just released the next sort of 10-year projection of where they think the space economy is going. They're projecting a growth by I think it's 30. Don't quote me on that. I think it's 2030, of 1.8 trillion in total is the growth of the space economy. Some caveats there, but it's roughly growing at about 9% a year. The nature of it is massively changing as well. So it very much was a sector which was only where really government labs, state-run governments was really their arena, I suppose you could say, because they're the only ones who could afford it. But in the last 10 years, coming back to why infrastructure is so important, think of it like railroads, I suppose. Once the infrastructure is made available to access space, then you start to see commercial opportunities. Comes with good and bad, but you start to see those commercial opportunities because they can now afford to do so. And so there's a huge, I'm just pointing here to the commercial bar, that would never have been there 10 years ago. So there's about at least half now of all space is done through commercial providers, commercial entities. Brings with its challenges, but it also brings opportunities. And it's kind of into that arena Australia comes into now. This is a great piece of software. It's free. So if you like playing with free software, this is from it's an Australian company called Sabre Astronautics, and that many of us know very well in the space sector. And they have some beautiful software for purchase, but they also have something called Tarot, which if you go onto their website, you can just put an email in, password in, and then what it does is it displays a view from space of all satellites today that are going around the Earth at different orbits and things. So it's very cool. And you can kind of move it around in 3D. I can't do it on this screen here, but I was playing with it last night. I got far too distracted, but it was very, very cool. But I wanted to show these two plots. So on the left, the one where you've got the sun in view, this is kind of what I'd call old space up until about 10 years ago. I just switched everything in what's called low Earth orbit off for this picture. But this is a very good view of what old space looks like. So you've got the Earth in the middle that's in eclipse there at the back. Do you see like a ring around the equator there? That's all your geostationary objects, geostationary satellites that have been there for probably tens of years or more. And you start to see ones that are drifting off depending on which country probably launched them in the first place. Geostationary orbits have the nice ability to rotate at the same speed that the Earth does. And so what that means is a satellite that's positioned, it's not necessarily a special orbit for any other reason. The reason they're all there is because they're able to stare right at us if it's above Australia, and they'll always be staring at us. So for communications, for Earth observation, things like this, you can see why that would be a really interesting orbit to be in. And then you have a series of ones in purple. Do you see those ones? They're the navigation satellites. So they're in MEO orbit for the most part. You need a grid to know where you are. If you think of a grid around you and it's all beeping at you, you know where you are relative to any of those things. That's what the navigation satellites do. And so again, that's old. It's not old tech, but it's old style tech, if that makes sense. So that's what old space looked like. But once I clicked on the button which said switch everything on that is on low Earth, it's in what's called low Earth orbit, the orbit that's closest to us on the ground without it falling into the atmosphere. You get this. So there's probably, I don't know, I'd say 100 times, maybe more, actually maybe more satellites in that shell low Earth orbit than what there is in the whole of old space on the left. And so when you think of a company like Starlink, which I'm sure you've heard, OneWeb, etc., they're offering in the case of Starlink, a communication service, right? This is them. Everything in blue there is Starlink. There's about 5,000 satellites. And they have a license for another 5,000 or 6,000 more, okay? The reason why they're there, can anyone think why? So I was at a class last week. I haven't really switched off my class yet. But can you think why commercial has gone to low Earth orbit? Nope. I think you said it already. It's cheaper. It's a commercial service, right? So it's cheaper to get to low Earth orbit than it is to geo, because it's not as far out the gravity well. So with advances in mass production, technology advances as well, it's all kind of come together for a company like SpaceX with a lot of investment behind it to offer a solution in low Earth orbit where you have thousands of satellites doing the job of $1 billion satellite sitting in geostationary. But it's not just, it doesn't just serve one country, it serves everyone, because it's a constellation that encompasses the entire planet. So you can see how powerful that is. Yes, and so there are other constellations there you can see, but when people talk about low Earth orbit, new space, new solutions, they're talking about that. They're talking about that thin shell, which is just above our atmosphere. Just a couple of slides on InSpace. You know, when I said I really wanted to bring a multidisciplinary community to InSpace to really understand not just the tech solutions of what we have at ANU that are new in the world and therefore could offer an opportunity, but also, you know, what about the policy that would need to go along with that? What about who is being impacted by this new technology? Scientists, or I'm a scientist, so I'm like, oh, tech's great, it's wonderful. And we're in ATSI of all things, but you know, we have to, you know, it's important to ask, well, tech is great, it's new, but what's actually it serving? You know, at the end of the day, who on the ground benefits from this and who's actually going to drive it? We went out across ANU and very quickly we got hands up from academics in schools as diverse as RegNet, which is in the College of Asia Pacifica group that studies regulation and new types of regulation, to economics, chemistry, biology for food growth, water purification, solar cell development out of College of Engineering, AI for remote infrastructure out of the School of Computer Science. And so the story just added very, very quickly. And it meant for a very diverse group of people, both disciplinary and also it, because it was new, I could then say, well, I really wanted at least to start with gender diversity. It's been something we want to aim for, and we'll build from that. I have to say, even 5 years ago, it was kind of, you were out there saying you wanted 50-50 gender. I don't know if you remember what it really was like that. I was like, oh, I'm not quite sure if I'm going to be able to get away with that, because I've got all these professors going, oh, watch out. Literally, it was like this. I kid you not, I'm not making this up. And it was like you were really kind of pushing the boundaries a little bit, you know, by saying, well, I think we should have 50-50 gender just to start with, you know, let's take it easy. You know, and because it was new, it was important to say so. And what happened was the opposite. I got 75% women or female identifying being part of the institute. We actually went the other way. So we had to try and go back this way, which was a nice problem to have. So it's, we're still about 70% women in the institute, both in academics, in the HQ and on the board. So it's very important to have it all the way through. It's very cool. And things have gone well. Well, we don't usually, you know, we're not always going out to glitzy events, but this is one that we did. We won several awards at the Australian Space Awards this year, and have pretty much every year. This is just some of the team there, and some of our mission specialists there as well too. So it's gone very well. So So I wanted now just to sort of look to the future a bit. And these are the 5 sort of key themes that InSpace itself is looking towards to build its, I suppose, its relationships, its business under for the next 5 years. And I'll just run through these. I'll run through these quite quickly, just explaining each one a little bit. Would love to hear your thoughts at the end, though, what you think about these ones. So in no particular order, space for a resilient Australia. I would like to say we used the word resilient 3 years ago. Now it's been used everywhere. So I'm not sure if resilience is the right word anymore, but I think you get the spirit of it. It's about facing a future of uncertainty, of increased events, especially weather related. How can we be using our connections? How can we be using our people on the ground and in unis and in industry to adapt to that? Not just respond, but adapt, and perhaps even then to change. So we have 2 missions under that right now. One is a bushfire resilience mission, which is working with Charles Darwin University and Indigenous Carbon Farming Network. And so this is using our capability at ANU, which is all about how do you predict, how do you measure flammability in eucalypts across the whole of Australia? And once you have that information pre-season, how can you work with groups on the ground that understand the land to be able to do something about it? So working at a city level, at a land management level, at a fiery level, working with communities to try and do something about that. The second theme is sort of future needs of a much more mobile and connected world. So what I mean by this is if you look at the demand for information, connectivity, wrapped into AI in the future, the predictions of what is needed to support that, and especially in a net zero way, is really interesting. Like, how do we fuel data centers of the future? How do we connect between them with security? How do we know truth in data? All these things are very, very important. So this is building off, for us, we like this theme because this is building off capability we have in quantum optical communications, for example, which can provide those higher data rates, which can provide that layer of security that will be needed in the future. The third theme is space sustainability. So you saw the plot of the planet with all those blue things around it. You know, we know what happens if you don't take domains seriously. We know what happens if you don't come together and think about, well, what do we want this to look like for the future? We just go about a commercial solution to start with and not really think about, well, what if or why, that kind of thing. So we were asked recently to sign up to the European Space Agency's Zero Debris Charter, which was a wonderful initiative, which we did. But, you know, when I signed it on behalf of the Institute, I thought, gosh, I really would like to come along with more. Not just I'm going to sign something, but I'm going to be doing something that actually will make a difference. It's not going to change everything, but at least what we're doing will make a big difference in what it's trying to do. And so to be able to solve this issue of space sustainability, it's a complex one. You need to come at it from both technical solutions that can be adopted by industry, working in parallel, hand in hand with the regulatory side of things, right? So, so this is a big theme for us, and we really feel like not just ANU, our whole community, given the extent of Australia, its cloud-free nights, its ability to look at the universe in a way that it can, our current industry that's grown out of the space sector is almost all linked to some kind of space sustainability, whether it's clearing up debris, moving satellites to new orbits to get out the way, measuring the atmosphere to make sure there aren't too many pollutants in there from launches going up and down, all of them have that kind of sense to it. So it made sense to us to bring all that together, to say to the world, well, you know what, we're not going to solve everything, but what we are going to do is going to make a big difference. The fourth one is return and launch economy. I'm highlighting this one because I think not just launch from Australia will be something that's done soon, but I think it's the ability of Australia to receive return launches from companies like SpaceX and others, get sort of refueled, our payloads put on there, for example, developing an economy around that, and then relaunching from Australia. I think that to me is what I see as Australia being quite unique in doing. We already have good examples of doing that with JAXA, Hayabusa mission, etc. It's hard to miss Australia, to be honest with you. It's a big country, so it's in the right hemisphere, etc. So I think that's a really great thing to focus on. And lastly is our last theme is about data equity from space. And this really came out of conversations working with the political scientists at the College of Asia Pacific as we've gone on this journey together hand in hand. Really it's about really who decides what we do in space. The data that therefore comes down from space, who is it for? Is it biased in any way? Or is it truly for everyone right now? And I would argue it probably isn't. So co-design needs to be there at the beginning, hearing everyone's voice as to why we do what we do in space. It's a little bit like the story of the astronaut suit. I'm not sure if you've heard of this, but when two women went up to the space station a few years ago, this is with NASA, the spacesuits they had didn't really fit very well because they were made for men, because men at that point had been the ones that had been going up. So that's kind of the bias kind of thing. Are we actually designing space for everyone or just a few people? I'll rush along. Yeah. How much time do I have?
Well, we're okay, but
okay, I'll be very quick. So the next few slides, I'm just going to go very quickly on. These are just some things that we're doing in the Institute. So the first project is called OzFuel. This is a project we're doing co-designing with the Bushfire Centre at ANU. Professor Marta Yebra is leading that. I mentioned this before. This is about driving a story of how can we minimize these kind of things happening. So if we were to know in advance to 25-meter level across all of Australia, what areas were likely to be more flammable than others with enough time to do something about it, how would we drive a different ecosystem? How would it work compared to what we're doing now? And that's what this mission is all about. Another project we're doing is in the area of space medicine, which surprises a lot of people when I tell them. This is being led out of the College of Health and Medicine. And it's about being able to make decisions about a person's well-being, health, remotely, essentially. Of course, space is one of the most remote locations. So we're using that as a catalyst, as it were, funding through the University Trailblazer program. And the intent here is to be able to develop the smarts, I suppose you could say, the wearables, the smarts, the electronics, to be able to make these decisions about someone's health and well-being in a remote location, but actually have this deployed at the ISS, the International Space Station. But the impact really, or in the future, it's really all about how do we offer curated healthcare in remote regions, essentially. How do we reduce the costs of doing this, because we know that's coming, and how can we make it more equitable? I mentioned communications before. One of the greatest strengths in Australia that we have is in optical manipulation of optical light, actually, broader than just ANU. So photonics, optical photonics, telescope design, adaptive optics, removing the blurriness of the atmosphere. And we've got a country that the extent of it and cloud-free nights are so, day and nights are so significant that it only takes three sites across Australia to do the same thing as what it would take, 50 telescopes across the UK or something like that. So we're pushing a quantum, well, we've already delivered a ground station at Mount Stromlo. Our sister site at University of Western Australia has an identical one to get on the west and east coast, which is really fantastic. But again, this is about changing how we do communication, moving it from the radio to the optical bands. You get more data doing it that way. You're able to encrypt it so that it's unhackable. Yeah, so I'm very excited about it. Please come to Mount Stromlo to see the ground station that we have up there. We're also working with collaborators and groups across the ANU to take our projects out to across the Asia Pacific, or the Indo-Pacific in particular. It's hard to do space just by yourselves. It's even though it might still be cheaper to get up to space, it's very much an international effort. And we're starting to see things that we can do with our collaborators and colleagues that are very close to us. So for example, in the top right here, when there was a volcanic eruption recently in the Tonga Island region, unfortunately, one of the first things it did is it snapped the only underwater cable going to the whole region. And so what was able to be used was actually an education, a CubeSat, an education satellite, which was being used to communicate and educate across universities in the region. We're able to switch that to be more of an emergency communication tool, such as the ability of these small constellations now to be agile. It's becoming, so these space solutions are becoming much more of a critical infrastructure now, a backup infrastructure to what we have already on the ground. I'm just going through these quickly. This is my very last second. Am I okay?
Sure.
Because I can just turn. Okay, okay. And lastly, something I'm very keen on is our developing national sovereign capabilities, infrastructure to pivot to space, to underpin it. And so, for example, this very blue, I'm not sure if that's green or blue, NSQN stands for the National Space Qualification Network. And what we were able to do was to recognize that, because, I mean, space is still hard to design for. It's not instinctive if you're not from the space sector. But we wanted a lot of our industries to be able to access space in a way that their products were going to survive. And so we realized that if we grab together not just ANUs, but the nation's top radiation and non-radiation space infrastructure at ANSTO, University of Wollongong, at ANU, at Mount Stromlo, if we brought them all together to offer an easy front door for broader industry to be able to get their equipment tested and up and matured, they could then enter global supply chains where they wouldn't have been able to do so before. And that's leverage. I like that story because it's leveraging decades of investment into the nuclear science community in Australia, which is resulted in these beamlines that are you can't just throw one of those together overnight. Like, these cost $500 million each to put together, probably more. And most countries don't have access to that kind of equipment. So Australia has that's just one small, big example of space isn't just what you think it is. There's a whole ecosystem underneath it, of which Australia has a huge amount to offer. In this case, it was radiation facilities from the nuclear science investment, but you're also talking about, think of Earth observation investment in GA and CSIRO, for example. This is really important for how we translate the impact of what we do. Come see us, 121 Marcus Clark Street. This is us here. And you can learn more by scanning that very big QR code. Thank you.
Thank you very much.
That was excellent. Thank you for that. I was going to start off by saying, you know, after looking at one of our national capabilities, we're going to zoom out and take a big picture approach, but I don't quite know how I can have a big picture approach that's bigger than space. So I probably should have come up with a better analogy than that one. So as many of you can probably tell, I'm not Eleanor Huntington. I'm Peter Derbyshire, the Director of Policy and International Affairs here at ATSE. And when we're talking about national capabilities, I thought it was a good opportunity to look at the launch today of Australia's National Science Priorities and Science Statement. Because when you think about national capabilities, you think about capability to do what and why. What is the reason for us needing this national capability? Or even better yet, what is the reason for having the sovereign capability? Because these are two different things. John and I had an earlier discussion about what actually is national capability. And I tend to boil it down to fairly simple definitions of it's the ability for the nation to do the thing, whatever that thing might be. Now, when you think about that more deeply, you start asking the questions about what is the capability to do the thing? How long can we do the thing? Do we have the skills to do the things? We have a lovely space capability we've just talked about here, but is it going to be much use if we don't have the skills to do the research into the space, if we don't have the funding to develop the infrastructure to do the launches? So when we think about capabilities, we really need to think about what is the guts of those things. A similar and my personal favourite example is solar panels. We have the capabilities to put solar panels on Australian roofs all over the country, and we've done exceptionally well at doing that. But is that capability a sovereign capability? No, we're required to import those solar panels from overseas. And is it a very resilient and reliable one? That depends on geopolitics, that depends on economies, that depends on whether or not we're the first in line to get it. We've all come out of the pandemic. We all know we weren't quite first of the queue to get the viruses, the vaccines rather. So did we really have the national capability to develop the virus vaccines here in Australia? Something we're developing now, but something we didn't have before. So I'm going to ramble very, very shortly about this because I think it's more important we have a bit of a discussion about some of the lovely talking points earlier, and as well how do the national science priorities and how we achieve them. So I'm going to skip over press the button, Kronk. Thanks, Luke. I was going to skip over this as well. So today's national science statement that came out, it's a fairly simple thing, but quite powerful, I think. Through science and innovation, Australia will develop new industries that drive a dynamic economy, provide well-paid jobs, improve our quality of life, preserve our unique environments, and build a future made in Australia. Now, if you look at those 5 imperatives that underpinned this national science statement, you get a very clear view of what might be considered the capabilities to undertake that national science statement. It's everything from making sure we have Australian scientists, institutions, and infrastructure to shape the future, a diverse, skilled workforce, having science at the centre of Australian industry, embracing science to drive Australia's regional and global interest, and a science system prepared for future challenges. So when I look at the science statement, which is a statement for our 10-year plan for science and research in Australia, I look at those 5 imperatives and think, these are the capabilities we are striving to achieve, which is great because then if I look at the ATSE policy priorities, it's pretty much the same thing. I always love it when a plan comes together. But I also look at our priorities and what we do here at ATSE in a way of capabilities. Mitigating and adapting to climate change. That's what we want to achieve. How are we going to do that? By collaborating, translating, and commercialising Australian research. What do we need to do that? What's the capability? Inspiring and educating young people in STEM, because we need a diverse, well-educated STEM workforce to achieve that. So that is one example of a capability that is something that we need to achieve in order to do the thing, which is mitigate and adapt to climate change. Now, the other part of the policy priorities is the priorities themselves. These are the ones that came out this morning. You will see that there are 5 of them. I'm not going to read out all 5 of them because I'm assuming everyone can have the chance to have a look at them or have a look at them on the website. But what I've done is I've gone through and pulled out all of the different critical research priority areas that fall within each of the priorities and had a look at what are some of the capabilities we need to develop to achieve these priorities. And they're not comprehensive. I did this morning because they were only launched this morning. So feel free to add some, take some, question some. But what we're really looking at here is the capability to advance and develop critical technologies. This doesn't necessarily mean we have to build all of these critical technologies in Australia. It can mean that we work with our partner countries to develop critical technologies internationally. The capability to develop new technologies in areas such as critical minerals, renewable energy, and circular economy. These are the capabilities that will help transition us to a net zero future. There were others, as I said, but feel free to have a look at them as they go. And then we look through all of the other policy, the national science and research priorities, and we see that there are some ongoing themes that build up on these. These themes include areas of developing the critical technologies, developing a data and infrastructure network that allows us to share information in health, in circular economy, in climate, in the environment, being able to build specific capabilities in some areas, such as Antarctic research, and being able to secure a system that is built for all of Australians, all of Australian scientists, that is diverse, that is supportive, that is culturally safe, and that can provide the next generation of STEM workforce. So looking at these, I see this as the ability to do the thing, which is develop the new technologies, do the research, do the commercialization, the skills for the people to do this, developing the new STEM skilled workforce and making sure it's a safe and resilient system for these people to work in, and then making sure we're working with our international partners, because we are not going to be able to develop all of these things in Australia, but national capability, as I said, doesn't necessarily mean sovereign capability. It means the ability to do the thing. So if we want to build, if we want to bring in, as an example we had this morning of microprocessors and the like, it doesn't necessarily mean we have to build them here, but we have to ensure we have a steady supply chain to bring them in. That's where we think about national capability. So I'm going to, as I said, make this very short because I think this is a better thing to have as a discussion rather than me talking at you. Told you I'd be short, John.
Yeah, thanks, Peter. That's wonderful. Very good. Great. The focus to the broad.
Sure, the floor is yours. Well, thank you very much, Peter, for distinguishing between national Thanks, Peter, for giving that clear, important distinction between national capability and sovereign capability. I think that's very important to bear in mind. And I also really want to thank Anna for an amazingly interesting talk about the state of at least ANU's efforts around space research and the huge amount of growth that's going on in that space and the opportunities that hopefully our future generations will be able to take advantage of. So a couple of really good talks. I'd like to open it to the floor for questions. I'll start with, oh, they're written up there. Okay, I can see them here. So I've got a question here from David Cohen. Hi, Anna. Australia's commercial space interests are driven by many SME with little finances to access many expensive infrastructure. How should we address this to keep SMEs viable in the space industry? Are you happy to address that one, Anna? And I think you have to come back to that. We'll just have to swap over.
Oh, we do have the.
Oh, you have a roving mic. Okay.
We have a roving mic.
Okay. I'll swap. Sit here.
Hi, David. I think that's David Cohen from ANSTO. David Cohen, is that correct? We'll start typing in a minute. Okay. Well, yeah. So that's a really good question. So when I first came out here when I came to ANU, I inherited a space test facility up at Mount Stromlo, and this was when I was just fully I had my astronomer hat on, not my space hat on at that point in time, if that makes sense. And no one was using it, and I was like, "It's so flashy! How can no one be using this thing? It's so amazing!" And I thought, well, I'm going to have to do something about this. And so I went to the SMEs at the time, or the companies at the time that were in Australia. This was around about 2017. And I said, what can we do? How can we help you use this? We know you want to be deploying things in space. I know you want to be using this. And it really just came down to cost. I mean, they just didn't have the money, not even a few $1,000s to make it there and work with us. So I was like, okay. So I went out to 4 partners we didn't have an Australian space agency then. So I went to the New Zealand Space Agency, who were already using our facility, to UNSW Canberra, ANU, DST, and the ACT government was the last one. I'd got in trouble if I'd forgotten that one. And I said, hey, folks, we do have more money than these companies. How about we just for 2 years, we'll do a partnership. it'll pay for the facilities and will be free access for everyone, anyone who wanted to use it. And it was amazing. I mean, it really just changed, it catalyzed everything we did at that point in time. Our companies what we're seeing now is that they can actually, the ones that are doing better business, they can afford to use the facilities, at least for the non-radiation ones, which are a bit cheaper. But again, you need to morph your business model to react to your community that want to use it, you know? So when they change, you have to change. And that's the answer there. Something like ANSTO, which is where David Cohen is from, gets NCRIS money, for example. So NCRIS is changing to offer funding for industry access. So I think we'll see more of that happen. But yes, you morph your business model to morph with your growing industry sector. It's not rocket science, as they say.
And the increasing buckets of money to support innovation in SMEs as well. So those as well.
That's right. That's right. It's never one size fits all. Tiered approaches are good too. Some people are more than happy to pay because they get what they need. Others are happy to wait and they'll come in underneath. So it's.
Thank you, Anna. Luke, is that the only question we've had online so far? I'll open it to the room. Any questions from the room? Because I've got a couple of questions. Nobody else has. I've got plenty of questions. John?
Yeah, I've got one at least. Fascinating, really good. Yeah, thank you. That's easy in that one. Oops. It's a fascinating presentation and looking at those two images of low Earth satellites, the Starlinks and so on and so forth, but also the higher geostationary older satellites. And then we hear a lot about the degradation. I'm thinking of the space junk and that sort of, which I think of as being pollution in space. And as satellites age, what happens next? Are we going to see an improvement in the amount of space junk, and can that be managed? And will all aging satellites add to that? Or do we have other ways to think about this for the future?
No, that's a really good question. So what I didn't show on the plot, I didn't click on the debris box, because if that goes on, then you'll just all leave. It's all over. No, not quite. I mean, those pixels are, anyway, so it's not quite representative. But yes, debris is a real issue. And the closer you are to Earth, the more of an issue it is. And I don't like the idea of polluting any of space, but from a practical perspective, that thin shell, low Earth orbit, that's the key. Because if that's the one that will get filled up more quickly, it's the one where a lot of debris exists and it's a limited amount of space. And it's the one where if we don't keep track of what's going on, you can actually get something called, there's even a name for it, called the Kessler syndrome, which is these things are going at 8 kilometers per second. Things don't collide in space, they disintegrate, right? These velocities are hypersonic. So what happens is if it's so populated, it gets better. I'm sorry, I'm just giving you the worst bit first. If you can have a collision which then creates a debris cloud, that debris cloud creates another debris cloud and so on and so forth, and it gets out of control. And at that point, we're not even allowed to travel through low Earth orbit. And if we can't get through low Earth orbit, then we're all stuck. It's a big problem. So it is important to take this very seriously now. So I think the solution is, like most things, you have to come at it from different solutions. If you have to come at it from different ways. So we need to think more about how do we make satellites up there more, increase their longevity. So there's a company called Space Machines, which is an Australian company. Its business model is about how do we actually move satellites to different orbits, how do we refuel satellites in the future, just give them a longer life. So, things don't age as much in a way up in space. So if you can give things a longer life, then you haven't got to launch another satellite. It's a simple premise, but it's quite powerful. You have technologies also that, so some companies are looking at technologies where they can clean up debris. They can go up, they've got nets, they've got other things where they're able to, to be able to clean debris up. You've got a company in Adelaide called Neumann Space, which is developing propulsion based on waste materials that are up in space. So these are just a few examples of, even just in Australia, what companies are sort of like leveraging towards. But it'll come with better systems design, better materials, so things don't fall off when they go up into space and things like this. It's a whole sort of ecosystem response. I suppose that I'm not a climate change expert at all, but I imagine there's some similarity between the two. You know, when you've got complex issues going on, you've got to come at it from different angles. And all of that also is, how do you get everyone to sign up to the same, the same sort of, is space really a global commons? I think at the end of it, is it or isn't it? If it is, how do you get everyone to sign up to that? A bit like how we have done for Antarctica, but how we haven't done it for the moon yet. That makes sense.
Okay. Anybody else got it?
I'll ask the question and you repeat it back. It's really to Peter. Okay. So national research priorities are all well and good, but if there's nothing behind it, they just feel good. So what do we have a sense of a commitment from government to actually direct resources into these areas?
Thank you. So for those online, Joe's just asked whether what's behind the national science priorities. How do we get there? Because having the priorities are good, but what are the next steps? And it's an excellent question. We have seen at the moment, we have a research and development review of the whole sector that is being undertaken by the Department of Industry in partnership with the Department of Treasury and Department of Education. That review is set to look at the whole sector, funding, opportunities, the collaboration between between industry, research funding, industry, academia and government and philanthropy, and to see how that all works together. That review is meant to highlight the opportunities to grow the funding, because none of these capabilities can be achieved without a boost in research funding. The other part of it is, of course, the University Accords review, which came out this year, thanks, Surya, which is focusing on the skills development part. And of course, we've also done our own work here at ATSE on developing the STEM skills workforce, which some of those recommendations have been taken up by government and are being developed forward. So I kind of see it as a three-pronged approach. If the skills need to happen, the funding needs to be improved, and then the third part is the opportunity to really actually turn our research into commercialized, translated, collaborated products that can help us achieve those priorities. So that's where ATSE really has a place to play in developing sort of an approach to fixing up the research innovation system so that we can commercialize our products. We can translate it into new policies, new international approaches, new capabilities. So that's what's needed. The answers aren't all there and they're not all completed yet, but that's where things seem to be going. So I don't want to say everything hinges on a review, but a lot rides on making sure that review is effective and taken up across this and the next government.
Yeah, that takes me a bit back to what Brian Schmidt said at the oration last year about Australia's research and development capacity being subsidised by international investment, which again plays on this thing of sovereign versus national. So and I've got a question for you around your Science for Resilient Australia theme. Now, we live on a continent in which vast areas of it are extremely remote. And we have to be able, in order to be able to develop a sustainable future for Australia, we have to be able to Earth observe our water resources, our natural resources, our biodiversity, all of those components. And yet we don't have our own, we don't have our own satellites, right? So we can't position satellites where we want them to be able to do that. And this is this play on sovereign versus national capability. How do we get, how long will it take us, or how are we going to be able to get to the point where we are going to be able to Earth observe at the right level of focus, but also the right level of frequency? Because the biggest challenge is that the satellites just aren't coming over quick enough to be able to measure change. So how are we going to do that nationally?
Well, I think, you can't, I think you have to focus on those things that matter to you. All of this is going to be really straightforward, but harder to implement in practice for some reasons that I don't understand. But you know, you borrow what you can, you pay for what you need. Okay, so we're already starting to see issues with resources being as satellites, for example. I think there was a recent, the Himawari satellite was recently retasked away from Australia because there was a cyclone going to Japan or something, and it's a satellite owned by Japan. And so we couldn't use it for our own needs, which was flooding, I think, in Queensland or something like that. We're also starting to see if there are data glitches in some of the Iridium satellites, then we're starting to see our farmers are struggling a little bit because they're not getting that connectivity, and connectivity is money for them, right? So we're starting to see a little bit of fraying around the edges, I have to say, already. And I think, so it's about understanding what, with the resources we have, where we can go, and what can no one else provide us? And that's the kind of thing that you want to say is your critical infrastructure that you need to fund. And I, it's been an interesting 7 years being back. I've never seen so many sort of circular discussions about things that end up going like, I don't know where they end up going. Like, I think sometimes it's easy. You just got to have someone with enough guts to say it.
Right.
And I think, you know, and I'm saying this is through inspiration, and I hope it comes out this way, but I was at a meeting a couple of weeks ago where the Minister for Space from New Zealand and the New Zealand New Zealand government spoke, and she was incredibly proud about how New Zealand had framed its space policy and what it was going to go after and what it wasn't. And they are now, and I hadn't appreciated this, New Zealand are the fourth, you know, the big four launching satellites right now. New Zealand are number 4. And there's a big drop from 4th to 5th. So it's like US, Russia, China, New Zealand.
Yeah.
Exactly. And so I don't think it's true to worry about not being able to do any of this stuff. You know, like it's what's important to us. What can we leverage on the ground? Our communities on the ground. What value do they bring that makes it unique on the world stage? And then investing in that. It's okay if some of it doesn't get delivered, but you learn a lot from doing it, I think. So, yeah.
Will it be a while before we launch our own satellites?
We are launching our own satellites.
Yeah.
I think there's, we had 7 or 8 come through our facility.
Okay.
And in fact, the SmartSat are just about to launch Community, aren't they? Yeah, so, well,
Okay.
Michaela should say a lot more about this than I do.
Rockets, presumably. Yeah.
Well, you know,
Yeah.
that's okay.
That's
but
okay.
but these are satellites that are catered for Australian data and decisions, I suppose. And small steps, yes. We had the National Mission Series that didn't quite make it through, but hopefully that will come round again.
Okay, thank you. Question online from Bruce Middleton. What is the basis for positive, I think, expectations of the results of a review which includes Treasury, well known for its resistance to spending on space?
What? I thought that was a question for Peter. Actually,
that might be
I think it might be a bit of both. If you want to take the first shot, if you
There's a
like.
little bit of cynicism in there as well. Maybe.
Surely not. What is the basis for expectations of the results of a review, which includes Treasury?
How can we-
Is that for me,
Treasury
Bruce? Is that for me, or is that for
Yeah.
Peter?
I think it's a bit of a, I'm happy to go first if you want to add anything about space. Look, I mean, the positive, I'm known for being the most pessimistic, positive person you'll ever meet, in that I always have hope that things can get better, but I sometimes wonder if they ever will. That being said, this is an opportunity where we can look at not just the, approach of we need to get more research funding into research, but really looking at what it is that research then develops to achieve things like the national science priorities. And I think the approach we've been looking at here at ATSI is not just how do we achieve the national science priorities through better funded research, through long-term funding in research, but also what is it we're missing out on? What is it we're relying on other countries for our national capability? That should be sovereign capability. You know, should we be building Australian solar panels here in Australia? Are we okay with it being overseas? Should we be developing our own tests for vaccine viruses, like the rapid antigen tests? We develop them here in Australia. They're manufactured overseas. Is that the approach we need to take? And I think the research and development review needs to take all that into consideration, not just what are the amazing things we do in Australian science and technology, but what are the things we're deciding we aren't doing or we shouldn't be doing because we're not funding it properly. Space might be one of those things. If we're not funding it properly, are we deciding that it's okay to have New Zealand being the 4th highest launch location, where, you know, Australia is huge and a great launch destination, I would say.
Yeah, well, I don't think the Treasury is resistant spending spending on space when, you know, GA just received $550 million to join Landsat, right? And also $300 million to do SBAS, which is a super brilliant enhanced capability and you know, precision data, you know, across the region. So it's not. I think we shouldn't be spending any industry for that industry's sake. I mean, I think it has to all be well thought through. But I don't think. Yeah. So we're not spending on space. I mean, in the last 10 years, it's probably a couple of billion spent on space. If you take in defence, it's probably up at the 6 or 7 billion. It's just 4 of that went overseas. It's just a matter of what do we need to be doing here versus what do we need to be doing overseas. I mean, sorry, it's exactly what Peter said.
Yeah.
But we are a little risky here. We're risky to the point where we end up being a risk. Honestly, I have to say, I'm an Australian now, so I feel like I can criticise Australians. Okay, I've got my Australian flag on top of me. So, right, like I do. I think we've spent so long trying to figure out what to do, then we've already missed the boat.
Yeah.
You know, like sometimes just do it.
Thank you, Anna. Other questions?
That's my American.
And then I have a couple more questions. I can try and wait for 45. Thanks.
So speaking about sovereign capability and deciding what we should and shouldn't do here in Australia, what are the key things for space that Australia must do ourselves?
I think it kind of is split between opportunities and the resilient story. So supply chains or climate adaptability. I think there's those two things. So yeah, and I'm starting to see. So on the resilience side, I kind of covered, I mean, a little bit already. You know, so I think that getting ahead and just mapping our own journey a little bit in how do we respond to what's coming. We know what's coming. Surely we can do better than what we're currently doing. And a part of that is a space angle, right? So I think that's important. On the opportunity side, look, I think, you know, I gave a talk with Eleanor Huntington, actually, of all people, 6 years ago. Sorry, hopefully I'm watching your question. And I got up there and I was asked about, okay, project 30 years ahead, 50 years ahead, what could Australia be doing? And I actually talked about, I thought I'd be a bit radical. I talked about off-world data centers. Yeah, I know. And which today I'm thinking is actually, I'm already seeing companies start up in it. So this is all about, again, the future of data, but where is it going to be? You know? And so, so when you come at it from a net zero perspective, how are we actually going to power the data centers of the future? We can go to Antarctica or the poles or something like that. But, you know, space kind of offers a sort of an interesting opportunity to be able to just offload that power generation in a way that's perhaps even achievable in 10, 20 years. But you still have to communicate and underpin that. And again, that's where our hub, our optical communications hub, tied into quantum and all this kind of stuff, it kind of like has a really nice story to it. So you can kind of think of Australia being this you know, ground-based driver of this hub in low Earth orbit for our data needs of the future, you know. And at the time I extended that actually out to the solar system, because I was told to be, you know, so how do we communicate to the solar systems? That's what I was talking about. But I never thought actually I would be thinking about how do we actually fuel power data centers in a net zero way in the future, in the not too distant future, when you're talking about, there's what, even today, the projections on what we need to, the calculations we need to be doing now with the advent of AI and everything else, it's huge. We just can't do it. Yeah, and I think in the space sustainability thing, I think is also really interesting because no one else wants to take it on. Because I think if you've got a space sector which is, which you've had one for a long time, you're kind of used to doing things a certain way, and sometimes that can hold you back. But we don't have any of that here. Like we've got open eyes into a sector that's growing, and we're starting to see alarm bells about what's actually going on, because we're not we don't have the primes pulling us back a little bit, right? So we don't have that. And so we've got a much fresher approach to how do you operate in space appropriately. And I remember being, if I may just say, I remember being on country about a year ago, invited to be with an elder. The space community was invited to be with elders and the community, and it was fascinating seeing the conversation of space there. So we had people come in from the space sector who were experts in doing Earth observation, and I think they came into it thinking, oh, everyone, the Indigenous elders are going to be really impressed about what we're doing, and to some extent they were, but then we'd already been explaining about the damage you can do when you go into space. Every time you go into space, there is a little bit of damage that you do. And so the first thing they said was, well, why are you going into space? Because I now know I want to care about this, and it's part of my sort of field. Everything from the ground up to infinity, we learn is something that's really, really, it's ownership and a care, I suppose. I'm not saying this very well, Michaela, but I hope you don't mind. And then he said, so why do you want to go? And she said, oh, well, we want to measure climate change or something. He said, well, I already know climate change is happening. I've been walking here for 50 years. It totally stopped her in her tracks. Like she's like, oh. So, but it was great because then it probed why this specific thing she was doing was, you could only do it from space. And when he realized that, he went, yes, I get that now. I can see why I would say yes to that. So it's the process, I think, is just as important as the product when it comes to space situational awareness. That sort of circular kind of process that's natural to our Indigenous communities and not to Western culture. I think that's really important here. And it's one that we can bring. This is our community. And so it resonates in a way that's really believable, rather than just products that are going to make a difference. So does that make sense?
Oh yeah, no, thanks.
I hope I hope that was okay.
I want to finish by thanking our two speakers, and particularly for Peter for stepping in at the last minute. And really interesting. I mean, I think maybe there's an opportunity for ATSI to do some kind of futures report about what we should be doing more in space, and also it links back to that national priority where we need to be incorporating Indigenous knowledge in what we do, which clearly was something you understood by doing through that process. But anyway, I want to thank you both very much for a very interesting discussion today, and we look forward to our next, I think it's the oration associated with the ACT division on the 10th of September, is that right?
September.
Which will be online.
The Vice Chancellor.
The Vice Chancellor.
And Genevieve Bill.
Yeah. So thank you, everyone. That's a round of applause. Thank you.